Hi students. In my previous couple of videos, I've covered what acids are, just as a quick review, and then I went on to cover what ionic compounds are and how to recognize them, and then what covalent compounds were. And at the very end of the last video, I included this portion up here about how to recognize acids, ionic compounds, and covalent compounds. And I have listed them in that order because it makes sense. A, B, C. It's easy to remember that way. A for acids, B for ionic compounds. So you can kind of remember it easier by saying bionic, but it's ionic compounds. And C for covalent compounds. And how to recognize them is provided at the very end of the previous video. Now, although I have ordered them in this way, A, B, C, because that makes alphabetic sense, we're actually going to work through these categories backward. We're going to first talk about how to generate the naming or the nomenclature of covalent compounds first. And the reason we're going to do that first is because they're the easiest, generally speaking. And they are probably the type of compound that you learned best how to name in your previous chemistry course. So hopefully that's going to be mostly review. Then we're going to go on and talk about ionic compound nomenclature. And you probably covered how to do this generally in your previous chemistry course. But we are going to expand this by referring to several new polyatomic ions that you probably haven't seen until this course and this chapter, in fact. And then as the very last portion of the nomenclature or naming portion of this chapter, we're going to talk about acids, because really you need to be able to recognize the polyatomic ions before you talk about acids. So although I categorize them as A, B, and C, we're going to review them in the reverse order because it goes from probably the easier to the more challenging rules. I think the acids are probably some of the more challenging ones to name. Okay? So with that in mind, we're going to start with covalent compounds. And I'm hoping that this is a review for you. And covalent compounds, you're probably taught that you have two nonmetals. And by that we mean two or more nonmetals. You can have multiple nonmetal atoms in the compound. But we need to make sure right now that we are talking about a covalent compound with two or more nonmetals and not a polyatomic ion, which is an ion cluster of two or more atoms that has a charge on it. So I'd like to take a look at these two examples just to illustrate this issue. The one on the left, NO2, that is a covalent compound, and it is nitrogen dioxide. The one on the right, however, is NO2 with a minus charge, and that minus charge right there indicates that this is not a covalent compound, but instead this is a polyatomic ion. And as you will see soon, this polyatomic ion is called nitrite. So this is the nitrite polyatomic ion. It's a relative of the nitrate, which is NO3 with a minus charge. This, however, is a covalent compound, and it's called nitrogen dioxide. So this is covalent compound, and this is a polyatomic ion. What is the dead giveaway? Well, it's that charge right there. If you see that charge, you are not dealing with a covalent compound. You are dealing with a polyatomic ion. This is rendered a little bit more challenging, even so, because sometimes that polyatomic ion is going to appear in a formula. So, for example, if I had this formula, there's no charge explicitly written there, but we still have to recognize that this is an ionic compound because of the metal in the first position is a dead giveaway. And in ionic compounds, the charges of the ions are not explicitly drawn. So in this case, even though we don't see the charge here, we have to recognize that is a nitrite ion. So covalent compounds can look very similar to polyatomic ions. And we're going to have to watch out to make sure that we look for the charges, to make sure that we're talking about which category they correctly belong to. Okay, now that I've mentioned that, we're going to get into the rules for naming covalent compounds. And remember the rules for naming, the word that we use for that is nomenclature. So this is the nomenclature for covalent compounds. So if I have a covalent compound, I name the first element, then I name the second element and I give it an IDE ending, and then I give each element a Greek prefix to designate its quantity. So a mono, di, tri, and so forth. The exception to this third rule is that the first element never takes the mono prefix. Okay? So we're going to apply these rules to this one right up here, and you'll see why its name is nitrogen dioxide. NO2, we know that it's a covalent compound. So we're going to apply the covalent naming system, the nomenclature for covalent compounds to it. We name the first element. First element is nitrogen, so there is nitrogen. We name the second element with an IDE ending. Well, the second element is an oxygen, so it would be written oxide, right? That would be an oxide. And then the third rule says give each element, the nitrogen and the oxide, a Greek prefix to designate its quantity, how many it has. And the exception to this, the first element never takes the mono prefix. So I'm not going to write mono nitrogen because that first element never takes the mono prefix. But that oxide would take the Greek prefix for 2, which is di. So at this point, we've got nitrogen dioxide, just following these 3 rules. Now, I don't have it listed here. It's listed later in the chapter, but I'm going to go ahead and make a note here in the margin so that you have it here at this section, what the Greek prefixes are. So Greek prefixes. Notice also that I generally do not capitalize the names of elements. So this is not a capital N, not a capital D. The exception to that is if the name of the element appears at the beginning of a sentence, then we would capitalize it as we would with any word at the beginning of a sentence. Okay, so Greek prefixes for 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay? So here we go. The Greek prefix for 1 is mono. M-O-N-O. The Greek prefix for 2 is di, di, not bi as in boy, but d as in dog. Okay? Bi is the Latin form for 2. Di is the Greek form for 2. 3 is T-R-I, tri. 4 is tetra, T-E-T-R-A, tetra. Okay? Not quatra, that's Latin, but tetra, T-E-T-R-A, for Greek. 5 is penta, P-E-N-T-A. 6 is hexa, H-E-X-A. 7 is hepta, H-E-P-T-A, hepta. 8 is octa, O-C-T-A. 9 is nona, N-O-N-A. And 10 is deca, D-E-C-A, not D-E-K-A. Okay? Those are the Greek prefixes, so you need to know those because you're going to be applying them as we do this nomenclature work for covalent compounds. So down below, I have some practice problems for you. I'm going to do the first one of each column, and then I'm going to let you do the others in each column. This first column, I'm giving you the formulas and asking you to write the name. In the next column, this is a different problem from that one. So in these problems, I'm giving you the name and then asking you to see if you can work backward from the name and reason your way through the rules to determine what the formula must be. Okay? So here we go. I'm going to do the first ones for us. Cl2O7. The first thing that I need to do whenever I am trying to do nomenclature is I have to categorize which category does that species belong. So I ask myself, A, is it an acid? B, is it ionic? C, is it covalent? And once I have determined which category it belongs to, then I know which rules to use. So A, is this an acid? Well, I don't see hydrogen in the first position or an aqueous state indicator, so this is not an acid. B, is this an ionic compound? Well, I look at the first element, and it is not a metal, and I don't have the NH4 in the beginning that would indicate the ammonium cation, so I know that this is not an ionic compound. Well, if it's not A, an acid, and it's not B, ionic, then it must be C, covalent. And sure enough, I have two or more nonmetals, and there's no charge on it, right? So this is a covalent compound. So I'm going to use the covalent naming rules. So rule number 1, I name the first element. The first element is a chlorine. Rule 2, I name the second element with an IDE ending. Well, that's an oxygen, and I'm going to give it an IDE ending as if it were an oxide ion, so it's oxide. And you notice I left a little space here, just in case I need some Greek prefixes. Because rule 3 says, give each element a Greek prefix to designate its quantity, and the exceptions, the first element never takes the mono prefix. I kind of rewrite this exception to say the first element never gets mono, right? So it's a little bit funny, but maybe you'll remember it. This first element never gets mono, okay? So there's a Greek prefix 2 here, and the Greek prefix for 2 is di. So it's dichlorine, all one word, dichlorine. And then there are 7 of those oxides, so it's going to be a heptaoxide. Heptaoxide. Dichlorine heptaoxide is the name of that compound. Now there is a linguistic variation. In English, you are allowed to drop the A in these prefixes. An A or an O can be dropped from the prefix if it immediately precedes an O. So this could also be written as heptoxide by dropping that A. The same thing happens with monooxide. We can drop that O in the mono and it becomes monoxide. And you've heard of that before, right? Carbon monoxide instead of carbon monooxide. So that's just a linguistic variation, and it crops up a lot. So you're welcome to do that. In fact, for some of them, it's expected that you will do that, like carbon monoxide. Monoxide is generally the preferred way of writing that. Okay? There are 2 more down there. I would like for you to pause the video and do just these 2. And when you're done with these 2, where you've written the names using the rules for these 2, then resume the video and I will write the answers here. And then after that, I will do the first one over here, and I'll let you do these 2. If you're feeling particularly frisky, you might want to go ahead and give them all a shot if you would like. Okay, pause the video now and do these 2. All right, coming back from pausing the video, we're going to take a look at this next one, P4O10. So the first thing we ask ourselves, we're going to categorize the compound. A, is it an acid? B, is it an ionic compound? Or C, is it covalent? Well, this does not have a hydrogen in the first position and an aqueous state indicator. So A, it's not an acid. B, it's not an ionic compound because this first position here does not have a metal or the ammonium cation. So it's not B, ionic. So it must be covalent. And sure enough, we have 2 or more nonmetals here. All right, so it's a covalent compound. We're going to use our covalent naming. Name the first element. That first element is a phosphorus. Okay. Name the second element with an IDE ending. That's an oxygen, so it gets an oxide. Oh, oxide. Rule 3, give each element a Greek prefix to designate its quantity, with the exception that the first element never gets mono. Okay? So we have 4 of these phosphoruses, and so that's a tetraphosphorus. All one word, tetraphosphorus. And we have 10 of these oxides, so that's a decaoxide. And I could have easily written that by dropping that A and calling it decoxide. So tetraphosphorus decaoxide, or tetraphosphorus decoxide. Both would be acceptable. Okay, next one. NO, capital N, capital O. Notice here that the capitalizations are important, because if I had written that O as a lowercase o, then it would be the symbol for the element nobelium. But that's not what this is. This is a nitrogen and an oxygen. So A, is it an acid? No, it's not an acid. B, is it ionic? No, it's not ionic. C, it must be covalent, and we have 2 or more nonmetals. So the covalent naming rule. Name the first element. And naming the first element, we get nitrogen. Name the second element with an IDE ending, that's oxide. And now give each element a Greek prefix to designate its quantity, with the exception that the first one never gets mono. So there's only 1 nitrogen, so you might think that's a mononitrogen, but first one never gets mono. So we leave that mono off of the first case. But the second one can take the mono prefix. So there we go, monooxide, or in the case of the mono prefix, we're just going to drop the O there and call it monoxide, nitrogen monoxide. Okay, those are the answers for those. Now I'd like for us to work backwards, see if we could reason backward. Given the name, I would like for us to try to work through to figure out what the formulas might be. So the first question that I'm going to do the first one, then I'll ask you to do the other 2. The first question we always ask in trying to write the names of the formulas is, what category does it belong to? So A, is this an acid? Well, I don't see the word acid written anywhere in here. So obviously this is not an acid, because acids have the word acid in their names. B, is it an ionic compound? Well, these are not ions. Bromine is not a metal, and it is not the ammonium cation, so this is not an ionic compound. So this must be C, a covalent compound. And sure enough, bromine and fluorine are both nonmetals. So we know that we used the covalent naming rules to name this. Well, the covalent naming rules said that we named the first element. Well, the first element was bromine, so this must have been the first element, Br. And the covalent naming rules next said, name the second element with an IDE ending. Well, fluoride must have come from a fluorine, right? Fluorine became a fluoride. And then the rules said that we must have given each element a Greek prefix to designate its quantity. Well, there's no prefix on the bromine, so that must mean that there was only 1 of them. But there's a tri-prefix on the fluoride, so that must mean there were 3 of them. And there we go. We have the correct formula for bromine trifluoride. So now I'd like for you to work through these other two problems if you haven't already. Pause the video, and while you've paused the video, see how these covalent naming rules were applied to generate these names and work backward to generate their formulas. Go for it. Okay, taking a look at the name sulfur hexabromide. A, is it an acid? Nope, no word acid here in the name. B, is it an ionic compound? The ionic compound would either have a metal in the first position or it would have the ammonium ion, and this does not. So this must be a covalent compound, and sure enough, sulfur and bromine are both nonmetals. So we must have named the first element, which is sulfur. That's the first element. We named the second element with an IDE ending, so it must have been originally a bromine that became that bromide. And then we gave each element a Greek prefix to show how many we have. There's no prefix on the sulfur, so there must have been one of them. And there's a hexa prefix, which means 6, on the bromide, so there must have been 6 of those bromides. SBr6. And there's the formula for sulfur hexabromide. Moving on, tetraarsenic decaoxide. We ask ourselves, is it an acid? The word acid is nowhere in this name. Is it ionic? Well, the first word is not a metal, and it is not the word ammonium, so this is not an ionic compound. So C, is it a covalent compound? Well, it's based on arsenic and oxygen, and sure enough, those are both nonmetals. It's true that arsenic is considered a metalloid because it's right there on that stair step, but for the purposes of this class, we're not going to be dealing with the subtleties of metalloids. We're just going to say if it's on one side of if it's to the right of the stair steps, we'll call it a nonmetal for now. And if it's on the left, we'll generally call it a metal. And there are some exceptions that we need to talk about, like hydrogen, but we're not going to get into the more subtle exceptions. So this is indeed a covalent compound. The tetraarsenic means that these started out as an arsenic, and I had 4 of them. And the decaoxide means it started out as an oxygen that became an oxide, and now I have 10 of them. Okay? Don't forget, AS is the symbol for arsenic. What is AR? That's argon, right? So the joke that I like to say to help people remember is to say, R, all the best pirates are gone, right? AR for argon, okay? All the best pirates are gone. I know it's cheesy, but now that I've said something silly, you'll probably remember it easier, okay? And that's how we use the nomenclature rules for covalent compounds. Be very careful not to confuse them with charged particles. And always ask yourself first whether a compound is A, an acid, B, ionic, or C, covalent, because each of those categories will have a different set of rules for naming them, okay? So what do you need to know? You need to know these rules for naming covalent compounds. You need to be able to recognize a covalent compound when you see it, and you need to know the Greek prefixes for numbers 1 through 10. And don't forget the exception. The first element never gets mono. Okay? There we go. And that's covalent nomenclature.